All right, welcome back everyone to this discussion paper on the IGCSE Cambridge paper 2 for chemistry multiple choice. Hopefully you all have prepped properly for the examination and you guys are ready for the paper. Overall MCQ shouldn't have been that difficult. We're going to go through this and see what type of questions we had. And of course, if you guys have any questions, feel free to let us know. All right, so let's start with the first question. 1. An ice cube melts. So it goes from a solid to a liquid. What happens to the molecules of water in the ice cube? So the molecules in the ice cube are packed tightly together like this in the solid, and in the pool of water, they're all now sort of farther away from each other. So this is simple, nothing too complicated, you don't have to worry too much about this. So they don't evaporate, they don't dissolve, they certainly don't lose energy, they all gain energy. Because to accomplish this, you likely need to heat the ice. So heat is applied, and as heat is applied, this causes a gain in energy. So yeah, fairly straightforward first question, nothing too complicated, let's move on. The diagram shows containers of gas at the same temperature. All containers have the same size. Which container contains gas at the highest pressure? So for highest pressure, you're going to need to look at the number of particles. Number of particles because the size is the same. So this has been standardized. So if they had different sizes, then maybe you could talk about, okay, maybe this one's larger, this one's shorter. But because they're all the same size, you're just going to count the number of particles. So this one over here has 6, this one has 5, this one has 2, and this one has 4. So the one that has the highest number of particles, this one, so it's going to be 8. It's interesting. So the reason we're looking at the number of particles is because pressure, this is a bit of a physics part, pressure is equal to force by area. So if your area is the same, it depends on force, and the force is dependent on the number of particles. Because the more number of particles you have, the more force, or let's say more force means these particles colliding with the walls of the container. So that's what they mean when they say that force. So this means collision with container wall, with walls of container. Right, again, another very simple question, nothing too complicated, so let's move on. Ammonia gas is reacted with hydrogen chloride gas using the apparatus shown. Solid ammonium chloride is produced. So which statement explains why the solid ammonium chloride is formed near to the hydrogen chloride? So let's take a look at aqueous ammonia. So this will be NH3, and hydrogen chloride, this is HCl. So the MR of ammonia is 14 plus 3, which is 17, and the MR of HCl is going to be 1 plus 35.5, so it's 36. So this is almost double the MR of ammonia. So that's why it's going to move slower. So hydrogen chloride will move slower as it is heavier. As it is heavier. So keeping that in mind, let's take a look. Which statement explains why the solid is formed near to the thing? So aqueous ammonia is a base, hydrogen chloride is an acid. This is irrelevant. Ammonia molecules diffuse more slowly than the hydrogen chloride molecules. We know that this is wrong. They move faster than HCl. Faster than HCl. Hydrogen chloride has a greater molecular mass than ammonia. That's the one. And only ammonia molecules diffuse in all directions at the same time. This is also incorrect. And so your answer is going to be C. Right, let's move on to the next question. The table shows information about 4 different particles. So we've got the nucleon number. Nucleon number is your proton plus neutron number. Neutron number. Then you have number of protons, number of neutrons, and number of electrons. So what are the values of W, X, Y, and Z? So for sodium, over here, the nucleon number is 23 and the number of protons is 11. So 23 is equal to 11 plus W. As a result, W is equal to 23 minus 11, which will give you 12. So let's look for which one has 12. We can immediately cut off A and B. Now let's look for which one is different each. So each one seems to have a different answer. So let's go by these step by step. Sodium ion. So whenever you see a plus sign, that means that it has lost one electron. And it's interesting. Oxygen usually forms so oxygen over here has a negative. So because it has a negative charge, it means that this gained 2 electrons. So it's important to keep that in mind as we move forward with our questions. Sodium ion, they're asking us the number of electrons. So number of electrons, because it's lost 1, is going to be 11 minus 1, and so X is going to be 10. For oxygen, number of neutrons, so 16 minus 8, so Y is equal to 8. And Z over here, because you have 2 extra electrons, this is going to be 10. So the answer, if we take a look at that, Z is 10, X is 10, Y is 8. Answer is going to be C. All right, moving on. A sample of element Q has 2 isotopes. The relative masses and abundances are shown. Relative mass of isotope 238, blah, blah. What is the relative atomic mass of the sample? So the way this goes is your formula is going to be percentage of one of them times the MR of 1 plus percentage of 2 times MR of 2, and you're going to divide all of this by 100 to get the relative atomic mass, RAM. So this one will be 238 times 66 plus 244 times 34, and then you divide all of this by 100, and you're going to get a nice clean answer of 230. So, excuse me, that's going to be our answer. A. So let's move on to the next question. Each element T has 2 isotopes, 12 and 14. We say one of these isotopes is correct. So for this one, what this essentially means is isotopes basically have same proton plus electrons and differ in neutrons. Now, chemical properties are affected by electrons, not neutrons. Electrons, not neutrons. So we can immediately get rid of A. They have the same nucleon number because the sum of the number of protons and electrons is the same. They don't have the same nucleon number, so this is not same. We're going to cut that out. And they have different positions in the periodic table because they have different numbers of neutrons, and that's not correct either. So this will be B. And this is also true. They have the same chemical properties because the same number of outer shell electrons, and periodic table is based on atomic number. And they also don't have different positions, they have the same positions. Sorry about that. Which 2 values are used to calculate the relative atomic mass of a sample of boron? So again, we need to figure out over here, you need to find out the percentage mass and the MR. So relative abundance basically means the percentage abundance and the relative mass of each boron isotope, so this is going to be B. Let's take a look at the other ones, total number of boron atoms. This you don't need. The relative mass of each boron isotope, total number of boron isotopes, you don't also need this. You just need the percentage abundance. All right, let's move on to question 8. When 65 grams of zinc reacts with 32 grams of sulfur, 97 grams of zinc sulfide is produced. When 65 grams of zinc reacts with 40 grams of sulfur, the mass of zinc sulfide produced is still 97 grams. So you don't need to do any maths over here. What they're basically saying over here is that 65 grams reacts with 32 grams of sulfur. And when you increase the number of sulfur to 40 grams, you still get the same number of zinc sulfide. So what is that telling us? It tells us that our limiting reagent isn't sulfur. So the limiting reagent is not sulfur, but it's zinc. It's zinc. And so we find over here zinc is the limiting reactant, and that's our answer. 9. Which row identifies the positive and negative particles present in a giant metallic lattice? In a giant metallic lattice, you have a sea of positive ions. Not a sea, you have a center of positive metal ions, and these are surrounded by a sea of delocalized electrons. So that's what it sort of looks like. And these are your delocalized electrons. And if you're having trouble trying to figure out which one is anion and which one is cation, the way I remember it are cats are positive. So you can also turn this into a pun and write positive. So that's how I remember what is that. So you can immediately cut out anions, and you can also cut out this one that has anions over here, and you're going to get your answer, which is D. The equation for the reaction between copper 2 oxide and ammonia is given. Which statement about this reaction are correct? So let's figure out what statement 1 is saying. 80 grams of copper reacts exactly with 17 grams of ammonia. So 80 grams of copper 2 oxide would be 80 by 80, which is 1 mole. But here's the thing. It's in the molar ratio of 3:2. So for every 3 moles of copper oxide, you need 2 moles of ammonia. So if you have 1 mole, then you're going to need, so this is going to be that, it's going to be 3:2. So for 1 mole, you need 2/3 moles of ammonia. NH3. So if we take a look at 17, ammonia has an NMR, so this would be 1 mole of ammonia. This is interesting. No, because you need, so 17 grams of ammonia over here, 17 by 17. So you're getting 1 mole. So whenever you say exactly, that means that you have no excess. But because we're seeing that you have 1 mole of ammonia, ammonia is in excess. NH3 in excess. So you immediately have to cut out 1. So this is not true. So you can cut off A, B, C, and you're left with D. 4 grams of copper reacts with excess ammonia to produce 3.2 grams of copper. So you see, they're mentioning over here the mass of water produced in this reaction is greater than the mass of nitrogen. Again, because 3:1, so that's correct, because this has a higher molar ratio. And over here, if you do the math, 4 grams of copper oxide, so 4 divided by 80 is 0.05 moles. And the molar ratio is 3:3, so 0.05 into the AR of copper into 64, and it is 3.2. So 3.2 is produced if you do 0.05 into, 64. It's equal to 3.2. So we're fine on that now. All right, moving on. The equation for the combustion of ethanol is shown. The relative molecular mass of ethanol is 46. Which statement about the reaction is correct? 4.6 gram moles of ethanol produces 4.4 grams of carbon dioxide. So the molar ratio is 1:2. So let's figure out the moles. 4.6 gram is 0.1 mole. And this produces 4.4. have to figure out the MR of carbon dioxide. So this is going to be 12 plus 24, which is 36. So 4.4 divided by 36 is equal to 0.122. Oh, sorry, what am I doing? Sort of zoned out there. So because we have 0.1 mole, you're going to have 0.2 moles of CO2. So 0.2 into 36, 0.2 into 36 is 7.2 grams. So this is incorrect. Of course, divided by 4.6 is... Oh, sorry, it's the opposite. 4.6 divided by 46 is 0.1, yeah. Sorry, fine. 92 grams of ethanol produces 88 grams of carbon dioxide and 108 grams of water. So there's two things we need to remember here. So over here, the molar ratio is 1:2:3. So let's figure it out. 92 grams is 92 divided by 46 is 2 moles. So you get 4 moles and you get 6 moles. So let's first calculate water. 6 into the MR of water is 18, because that's going to be 2 plus 16. So 6 into 18, 108 grams, that's fine. And carbon dioxide, 4 into 36, and this is not 88. This is actually 144 grams. So this is also incorrect. 138 grams of ethanol reacts with 32 grams of oxygen. So this is the molar ratio of 1:3. So 138 grams of ethanol is 138 divided by 46, 3 moles. So for 3 moles, you need 9 moles of oxygen. And I can already tell by looking at this amount, it's way too less, because oxygen itself has an MR of 32. So you're going to need a lot more than 32 grams. So this is also incorrect, which gives us the final answer of D. And let's just check to see if this is correct. 184 grams is 4 moles. 4 moles means that you're going to multiply this by 12, and then 12 into the MR of water, which is 18. 12 into 18 is 216. So this is correct. All right, moving on. The value of the Avogadro constant is 6.02 in 10 to the power 23. What is the total number of atoms in 2 moles of ammonia gas? What is the total number of atoms in 2 moles of ammonia gas? So 6.02 into 2. This is interesting. In 2 moles of ammonia gas. So 1 mole of any element has 6.02 into 10 to the power 23. So let me just do something real quick, make sure that we don't lose out on anything. First we're just going to write down ammonia. Ammonia is NH3. Now, what is the Avogadro constant say? It says that 1 mole of excuse me 1 second. Oh my god. Really sorry about that. I've had a bad cough, so that sort of threw me off. Anyways, 1 mole of any substance has this many atoms. Now, when Avogadro stated this, he did this in relation to the carbon-12 atom, so 12C. So that means that in 1 mole of just carbon, or 1 mole of any substance, any element, has this many atoms. Over here you have 4 different, I'm not going to say molecules. I'm going to say this has 4 different, 4 elements. Not 4 elements, because that's misleading. What I'm trying to say is that NH3. So you have 1 particle, so let's say particle, 4 particles. So because there's 4 particles, that means that the number of atoms is in 1 mole is 4 times Avogadro's constant. I hope that makes sense. It's because when he was defining the Avogadro constant, he was talking about only 1 particle. So 1 mole of 1 particle, rather. 1 mole of 1 particle. So because we have 4 particles in 1 mole of ammonia, 2 moles of ammonia will have 8 particles. So this will be 8 times 6.02. So if you do that, your answer will come out to 4.82 into 10 to the power 24. This is an interesting question. I really like that question. All right, 13. The equation for the combustion of hydrazine is shown. Okay. What is the overall enthalpy change for the combustion of 1 mole of hydrazine? All right, so this is very simple. Let's figure out bond breaking. So the bonds that are breaking is 1 of a nitrogen triple bond. You're breaking 4 nitrogen hydrogen, and you're breaking 1 oxygen oxygen. So this will be 944 plus 391 into 4 plus 496. So this is going to give you a value of, let me just put that into the calculator, 994 plus 391 into 4 plus 496, 3004. Minus 3000. Well, not minus. Let's not go into the symbols just yet. 3004. And now for bond formation, so bond forming is 1 nitrogen hydrogen. So 1 nitrogen nitrogen. So 1 times 944. And this will be 4 times OH. So 4 times 463. So that'll be 944 plus 4 into 463, which is 2796. So 3004 minus 2. So 2796 minus 3004. It's going to get you. Am I missing something over here? Nitrogen 1, 2, 3, 4. Oh, I'm so sorry. I got the wrong value. So this shouldn't be 944. This is going to be the nitrogen. Right. Should have spotted that earlier. So this will be 1 into nitrogen. So this is why it's important to read the question before you answer anything. So this will be 409, actually. So 409 plus 391 into 4 plus 496. So that's going to give us 2469. So this will be 2, 4, 6, and this will be 9. All right, so bond breaking is endothermic, and bond forming is exothermic. So to find del H, it's going to be bond form minus bond break. So if you put that in, it's going to be 2469 minus 2796, and you're going to get minus 327. So the answer is going to be A. All right. The concentration of a solution of aqueous sodium hydroxide is 0.5 mole per dm cube Which mass of sodium hydroxide is used to make 500 cm cubed of the solution? So we have to calculate the moles. So moles is equal to mole concentration into volume divided by 1000. Remember, this is only if the volume is in cm cube. So this will be 0.5 into 500 by 1000. So this becomes half. So this will be 0.5 into 0.5, which is 0.25. 0.25 moles. Now you need to figure out the MR of sodium hydroxide. So sodium hydroxide is NaOH. So the MR is going to be, so we'll go to our periodic table. Sodium is 23, oxygen is 16, so this will be 23 plus 16 plus 1, which is going to give you 40. So then you just multiply 40 with 0.25, 40 into 0.25, and the answer is going to be 10. So that's our answer. All right. The average bond energy for the carbon-hydrogen bond is 413 kilojoule per mole. What is the enthalpy change when 1 mole of methane molecules is formed from carbon and hydrogen atoms? It's an interesting question. So you're forming 1 mole of methane molecules. So 1 mole has, so if you draw methane, it'll be CH. So it looks something like this. One second, let me just put that over here. H, 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 and H. So average bond energy. So when you're forming bonds, this will be bond forming this is negative. So because you're forming 4 CH bonds, this will be 4 times minus 413. And if you do the math, you'll get minus 1652. Aqueous sodium thiosulfate reacts with dilute hydrochloric acid to form a yellow precipitate of sulfur. The precipitate forms more quickly when the reactants are heated. Which statements explain this observation? The reacting particles collide more frequently. Yes. The collisions between reacting particles have more energy. Yes. The activation energy of the reaction is lower. That is not true. Heating does not affect activation energy. Heating does not affect activation energy. So as a result, our answer is going to be A. Very clean, isn't too complicated. The reaction pathway for the reaction pathway diagram for the reaction between P and Q to form RNS is shown. Which letter represents the enthalpy change for the reaction? So of course, enthalpy change is always going to be del H is energy of product minus energy of reactant. So as a result, it's this part over here, so the answer is going to be C. B, this is your activation energy. So you don't need to worry about that. And D is sort of you don't need to worry about that. D or A, these are sort of nothing over here. All right, 18. Which equations show the underlying species acting as a reducing agent? So reducing agent reduces others and itself oxidize. So we're going to have to look for the reactants that reduce others and then oxidize itself. So let's take a look what we have. Fe2O3. So iron goes from having an oxidation state of +3 and oxygen goes from having -6 2, and carbon over here has one of -2, and oxygen has one of carbon has one of +2, and this becomes -2. So iron goes from +3 to 0, and carbon becomes oxidized, and oxygen sort of remains the same. So this is not a reducing agent because itself was reduced and it didn't raise anything else. In fact, it's more of an oxidizing agent if you ask me. So we can cut off this. Now the only difference between C and D is this is talking about 2 and 3, and this is talking about 3 and 4. So let's look at 2. So over here, iron starts off with an oxidation level of 0, and copper sulfate. So over here, oxygen, there has a oxygen over here is -8. So copper, let's assume, is +2, and sulfur is +6. So over here, iron becomes, so iron can go either +2 or +3. So let's assume that iron itself goes to +3. This is -8, and sulfur is +5. So it's reduced because it went from +6 to +5. And if you don't believe that one, then you can also look at copper. Copper goes from +2 to 0, +2 to 0. So over here, iron is acting as an oxidizing agent, reducing agent, because it reduced both copper and sulfur, and itself was oxidized. So our answer is going to be C. You can take a look at 3 and 4 if you want to, but I don't think it's necessary. So let's move on. 19. The ionic equation for the redox reaction between acidified manganate ions and iodide ions is shown. Which row shows the changes in oxidation number for manganese and for iodine during this reaction? So let's take a look at what's going on. For manganese, they're saying it goes from, so manganese over here, oxygen is -8, and manganese, because this has an overall charge of -1, so this will be +7. Let's look at where manganese is right now. So then it ends up having a charge of +2. This is interesting. It goes from +7 to 2+. And iodine goes from -1 to 0. So manganese never actually goes from negative, right? It's always been positive. So we can immediately cut these two out. And iodine doesn't go positive. It goes from -1 to 0. So we can also cut out this one because it's not positive. And so the answer is C. This is a very interesting question. And I kind of want to figure out what makes the manganese go from plus to +2. Because we can tell over here that it's MnO4, and it's an ion. 7 ions and iodide ions, and it goes from that to, maybe if you assume it's that, it's interesting. I'll have to look into that. In fact, just give me 1 second while I look into this. Okay, so I looked it up, and I think when the question was being made, they missed the numbers over here, so there should have been a +7 over here, +7. This is going to go from -10 to plus, and this will be -10 to 0. So I think they missed that during the question. So my apologies on behalf of the Fastpapers team. I'm not exactly sure how this happened. So yeah, this is my bad. So we're going to say that this was missing information. Alright, so let's move on. Question 20. The equation shows the equilibrium between dinitrogen tetroxide and nitrogen dioxide. The colors of the reactant and product are shown. The forward reaction is endothermic. So the forward reaction is endothermic. That means that when you add heat, more NO2 produced. So let's see what we've got. At equilibrium, the concentrations of the reactant and the product stay constant. So we're looking at students say not correct. So this is correct. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Very correct. When the pressure is increased, darker brown color is seen. So let's take a look. You have 1 mole here, and you have 2 moles here. So when you increase pressure, the side with less moles is favored. Moles is favored. So keeping that in mind, because this has more moles, you're actually going to see, this isn't correct. You're going to see brown color disappear. Brown color disappear. So as a result, this is the wrong statement, and so this is the answer. When the temperature is increased, darker brown color is seen. So this is correct, because once you add heat, and so instead of giving tick, I think because it might be confusing to those who just look at the paper, let's going to go across over here. So this is wrong, this is wrong, and this is wrong. The equation for the reaction between ammonia and oxygen is shown. Which two changes to the reaction conditions will both move the position of equilibrium to the right? Will both move the position of equilibrium to the right. So this is a exothermic. So because it's exothermic, raising temperature favors backward reaction. Backward reaction. So we're going to cut A and B from this. And then pressure. So this has a total of 9 moles, and this has a total of 10 moles. And as you know, increasing pressure favors the forward reaction. Increasing pressure will favor the backward reaction. Backward reaction. Because obviously the forward side has more moles. So we're looking to move equilibrium to the right. So you want to move it towards the right. So because of that, you're going to have to decrease the temperature and decrease the pressure. So that's correct. So this is the right. The equation for the complete combustion of methane is shown. The table shows some bond energies. What is the enthalpy change for this reaction? So bond breaking is 4 into 410 plus 2 into 496. So this is going to give you a value of 4 into 410 plus 2 into 496. And if you input that, you're going to get 2632. And bond forming is, you're going to get C00, so it's going to be 2 into 805 plus 2, so this will be 4 actually, 4 into 460, and that would be, so 2 into 805 plus 4 into 460, 3450. And as we've mentioned before, del H is equal to bond breaking minus bond forming. Bond break minus bond form. So 2632 minus 3450, you're going to get minus 818. Minus 818. And so the answer is going to be B. All right, the table shows some properties of noble gases. which row predicts the density and the boiling point of krypton. So we're noticing that density increases down the group, and boiling point, density and boiling point. And boiling point increases down the group. So we're going to have to find something in between 1.8, greater than 1.8, but less than 5.9, and something that is greater than minus 18, but less than 10. So let's see. This doesn't fit, this doesn't fit, and this doesn't fit either. I'm just looking at the boiling point, so that means that's going to be our answer. Nice. So this one is out, out, and out. So it's important for you to realize that if you assume that 0 is over here, going this way is an increase. So if you keep that in mind, then minus 10 is actually greater than minus 18. So you want any value that lies between here. So negative numbers is a bit difficult to grasp, but hopefully this should make it a bit more clear. 24, tennessine. Atomic number 117 is a manufactured element that is below acetine in group 7 of the periodic table. So if you look at acetine, it's over here. So we know that for group 7 elements, their melting point increases down the group. So this is going to be a salt. 25, lead 2 sulfate is an insoluble salt. Which method is suitable for obtaining pure solid lead 2 sulfate? So 25. So we're looking at an insoluble salt. So if it's insoluble, you're always going to obtain by filtration. So let's look at our options and see which one has filtration. Heat to evaporate all the water, no. Filter, collect the filtrate, crystallize, we don't need to crystallize, no crystallization, as insoluble, as it's insoluble. Titrate, crystallize, again, so this is correct, so the answer is going to be C. An iron nail is fully covered with zinc to prevent it from rusting. Which row describes the method of protection, explains why zinc is used to protect the iron nail? So one is called barrier method and sacrificial protection. Zinc is more reactive than iron. This is correct. This is also correct. Barriers method and sacrificial. Iron is more reactive than zinc. This statement is incorrect. Zinc is more reactive than iron. This isn't only sacrificial because you're also putting a barrier on it. So because of that, this answer is going to be 26. A. Which row gives the symbol equation for the formation of carbon monoxide and for the reduction of iron 3 oxide in a blast furnace? So again, this is if you've studied the blast furnace, then you should be able to answer this quite easily. So when your reduction iron 3 oxide, so these this one over here, this is +2, this is +2. So you can immediately cut this off because we're looking at iron 3 oxide. And over here, you're not forming carbon. So over here they say for the formation of carbon monoxide. This is forming carbon dioxide, so this is also wrong. So this is going to be D. Some halide ions are displaced from aqueous potassium halides by halogens. In which mixtures are the halide ions displaced? So for 28, we're looking at, let's see, potassium bromide and chlorine. So we're going to look at sort of the periodic table to help out how it comes. So it's going to be fluorine, chlorine, bromine, iodine. And fluorine displaces, so let me use a different color for all of them. So fluorine displaces all, chlorine displaces bromine and iodine, and bromine only displaces iodine. So let's see, bromide and chlorine. So chlorine will displace bromine. displaces Br. Potassium bromide and iodine. Iodine does not, no displacement. So we can immediately cut off anything that has two. So this and that will be gone. And potassium iodide and chlorine. Chlorine will displace. Displaces chlorine. And potassium chloride and iodine, no displacement. No displacement. And so your answer is going to be A. 29. Which statement about the extraction of aluminum by electrolysis is correct? Aluminum oxide is dissolved in molten cryolite to increase its melting point. Again, it says increase, so this is incorrect. It's used to decrease. At the cathode, oxygen ions lose electrons to form oxygen. Yes, again, cathode. So remember, cathode is the negative electrode. So this should be anode. And again, reaction of the anode, no, because this is a cation. So it'll be at the cathode. As a result, carbon in the graphite anode reacts with oxygen. It's forming carbon dioxide. So the answer is going to be 29. Let's see. Gases which cause acid rain form in car engines. These gases can be removed using a catalytic converter. Which equation represents the removal of one of these gases using a catalytic converter? So we're looking for greenhouse gases, right? So greenhouse gases, we're looking for gases that cause acid rain. So we're looking at stuff like carbon monoxide. For example, this just forms more carbon monoxide, so no. Over here, carbon dioxide plus nitrogen. This equation doesn't really seem correct. Like, I don't know how you're getting nitrogen gas from here. This really doesn't work out. Or actually, this feels... Actually, hold on, we'll come back to this. Because you're removing carbon monoxide and you're removing nitrogen oxide. Forming NO2, you're forming NO2. These are all... So this is going to be your answer, B. A sample of river water contains a high concentration of nitrates from fertilizers. Which statements about the river water are correct? Okay. It has a boiling point of 100 degrees Celsius. So because you've added impurities, impurities change BP. So this is incorrect, so you immediately can cut off these two. And now, again, we're looking at, since 2 is in both of them, we're going to look at 3 and 4. It turns anhydrous cobalt to chloride from pink to blue, and it turns anhydrous copper to sulfate from white to blue. So because it's water, so H2O turns anhydrous copper to sulfate from white to blue. So this is correct, and so your answer is going to be 3, 1, D. What is produced by the bacterial oxidation of ethanol? So when you oxidize ethanol, you're going to form ethanoic acid. This is interesting because this is why whenever you leave alcohol out in the open, it becomes oxidized and you get a, over here, ethyl ethanoate. So for those of you who don't know, vinegar is actually called ethanoic acid. So a joke that me and my friends we used to go to super shops and be like, oh my god, they're selling ethanoic acid here, but we really meant vinegar. So yeah, fun story. 32D. 33. An experiment to find the percentage of oxygen in 150 cm3 of polluted air is shown. The apparatus is left for 1 week. After this time, the volume of gas in the measuring cylinder is 122 cm3. So what is the percentage of oxygen to the nearest whole number in the polluted air? So that means that out of the 150 cm3, how much of that dissolved in the water? So 150 minus 122 means 28 cm3 dissolved in water. Dissolved in H2O. So that means that 28 by 150 into 100. So we're going to cut that. This will be 3. This will be 2. 28 into 2 is 56. And 56 divided by 3 is 18.66, which can be rounded to 19%. So the answer is going to be A. Which structures are structural isomers of each other? So let's take a look. Let's look at our options 1, 2, 3, and 4. So they're saying that 1 and 4 are structural isomers. So let's see if that's correct or not. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 10 hydrogen and 4 carbon. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 4 carbon and 10 hydrogen. So this is fine. Let's look at 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6 structural isomers of each other. This is 1, 2, 3, 4. This also has 1, 2, 3, 4. And this has also 10 carbon in that. This also has that. This is an interesting question. So since all of them seem to have the same configuration where you've got 4 carbon and 10 hydrogen, 4 carbon and 10 hydrogen. So if you take a look at this, this is actually, even though it might seem like it's a kink, it's basically the same as 1. So 1, 2, and 4 are actually the same molecule. Because if you draw them out in space, it'll look just like this. Whereas this is the only one that looks something like this. Whereas all of these, so if we do the skeletal formula, so 1, 2, 1, 2, and 4, they all look like, let's say for example this, 1, 2, 3, 4, but 3 is going to look like this and then like this. So these are all different. So it's going to be 1 and 3 only. Wow, very interesting question. Propan-1-ol is oxidized by acidified aqueous potassium manganate in a similar way to ethanol. Which compound is produced by the oxidation of propan-1-ol with acidified potassium manganate? 7. So if you acidify potassium manganate, you're going to get propanoic acid. And because it says propan-1-ol, so we're looking for that. This is not it. This is not it. This is ethyl. This is ethanoic acid. And so your answer is going to be D. So it's going to be oxidized to a, what do you call it? Carboxylic acid. Carboxylic acid. So these two are alcohols. Which equation represents the formation of polypropene from propene? So let's take a look at this. A seems to be on the right track. Let's see if this is any different. Propene, this is ethene. So not correct. This still has the double bond, so not correct. Double bond. And this just turned into polypropene. Polypropene. So the answer is going to be A. Ethanol is produced by the fermentation of aqueous glucose or by the catalytic addition of steam to ethene. Which rule shows some advantages and disadvantages of these procedures? So 37. Fermentation of aqueous glucose. This is not fast. Ethanol produced in batches, slow reaction, okay. Fast reaction, ethanol produced continuously. Ethanol is not produced continuously, so this isn't correct. Renewable raw material, glucose, technically okay. Almost pure ethanol formed, slow reaction, not correct. So your answer is going to be D. So let's move on to the next question. 38. Which pair of monomers is used to make this polymer? So you have an amide bond over here. So we're going to look for groups that have an amide group to them and also a carboxylic group. So you need a carboxyl group, and an amine group. So let's take a look at what we have over here. So this molecule, 1, 2, 3, 4. So so let's take a look at what, so we've got the amide group over here. We don't need these, honestly. Let me just erase this. So our amine group has to have 1, 2, 2 carbons. So all of these seem to, so because we need 2 carbons, we can immediately get rid of C and D. And let's go up. For our carboxyl group, we need 2 carbons. We need 1, 2, 3, 4. We need 4 carbons. So we can immediately cut this off, and it's going to be. So we need 4 carbon, and we need 2 carbon. All right, 39. A mixture of soluble substances can be separated by paper chromatography. Each substance can be identified using its RF value. Which formula shows how the RF value is calculated? So this is very straightforward. This is just going to be B. Yeah. And the last one, propenoic acid is an organic compound that is both an alkene and a carboxylic acid. The structure of propenoic acid is shown, which structure represents one repeat unit of the addition polymer formed from propenoic acid. So you're going to break this bond. So see, you're going to have one that goes up over here, and you're going to have one that is a COOH, and then this, so it's going to be B. And that's the paper. So hopefully this wasn't that difficult a paper. You guys were able to solve it without any pressure, without any hassle. Again, if you have any questions, feel free to reach out. And best of luck for your examinations. I know you guys are going to crush it. And once you're done, be sure to give yourselves a good break because you guys deserve it. And yeah, best of luck and see you in the next video.